Okay, today we're going to talk about molar mass. And if you remember, we talked about atomic mass units before. The atomic mass unit, or AMU, is the unit that we use when we're talking about the relative masses of single atoms, right? So the number on the periodic table, for instance, for lithium, it's 6.941. If we're talking about the mass of a single lithium atom, we're talking about 6.9 AMUs. Okay? Molar mass is that same number, but we change it to be grams. And then it becomes the mass of 1 mole of that element of compound. Okay? So the actual basis for molar mass on the periodic table is carbon 12. And the definition is that 1 mole equals 12 grams of carbon 12. Okay? So both AMUs and the gram, the numbers that refer to those can be found on the periodic table. So if I look up, let's say, fluorine, the periodic table says 19.00. If it's one atom of fluorine, it's going to weigh that many AMUs. If it's 1 mole of fluorine, it's going to weigh 19.00 grams. Right? This is one atom, and this is 6.02 times 10 to the 23rd atoms. Okay. Alright, so let's talk about comparisons. If we compare a mole of marshmallows and a mole of marbles, which has more particles? So that's like saying, if I compare a dozen eggs and a dozen muffins, which has more? Well, the answer is that they're the same. They're the same because a mole tells you how many. Okay? A dozen is always 12. A mole is always 6.02 times 10 to the 23rd. But which has more mass? Okay. So if I were to say I had a dozen feathers or a dozen bricks, which has more mass? It'd be obvious it's going to be the bricks, right? So if I have a mole of feathers or a mole of bricks, I'm going to have a lot more mass with the bricks. So, go back to here. If I have a mole of marshmallows or a mole of marbles, I'm going to have a lot more mass with the marbles. So, what's the molar mass of the following items? Well, we can look at our periodic table. So, if you take your periodic table out and you look for the number on the periodic table, what you will see is 1 mole. The atomic mass of nickel is 58.69, and because we're talking about a mole of those, the units will be grams. If we look it up for aluminum, what we see on the periodic table for the atomic mass, 26.98. Because it's a mole, it's grams. And oxygen, 16.0 grams. Now, if we want to know the mass of O2, this 2 tells us we have 2 atoms. So I have to take 2 atoms times each one weighs 16.00 grams. That's going to give me 32.00 grams of O2. Okay? What's the molar mass of NaCl? Sodium chloride, also known as table salt, right? Well, I can look up sodium in the periodic table. I've got 1 atom. Each of those weighs 23.00 grams. I have chlorine. I have 1 atom. Each weighs 35.45 grams. I add those up and I get 58.45 grams, or grams per mole, right? this is a little bit more complicated. This is calcium nitrate. So let's draw what we have. Actually, we have a calcium, and attached to it we have two of these. So that is an NO3. I've got two of those attached. So this is what we're talking about. So let me see. I have one calcium. How many nitrogens do I have? There's one inside multiplied times two outside, which are these two. I've got two nitrogen. And how many oxygens would I have? I've got these three times this two is six, which is these six. 1, 2, 3, 4, 5, 6. Okay, now I can look up the molar masses. And for calcium, it's going to be, let's see, 40.08 grams. Nitrogen is going to be 14.01 grams. Oxygen is 16.00 grams. I multiply these out, and I get 40.08 grams, 28.02 grams, and 96.00 grams, for a grand total of 164.10 grams. That's 164. Okay. Sometimes we see a formula for something called a hydrate. A hydrate means that it's got, as part of the formula for the compound, it's got waters in the structure. So what this is 1 copper sulfate. And this dot, I know in math that means times, but in chemistry it means plus in this case. So what I have is a copper sulfate, and it's surrounded by 5 waters. And we call it a penta. Penta means, prefix means 5. Pentahydrate. So that's what we have. So the easiest way to do these is we're going to take copper, we've got 1 atom, sulfur, we have 1 atom, oxygen, we have 4, and then we have 5 waters. And the reason we do that is because we do this a lot, and it's good to just know what the molar mass of water is, which enough of this and you'll know it by heart. 63.55 grams for copper, 32.01 grams for sulfur, 16.00 grams for oxygen. Water is going to be 2 times 1.01 grams for hydrogen, oxygen 1 times 16.00 grams. This is going to be 2.02, and I'm going to end up with 18.02. So 5 times 18.02 grams. I'm going to add all that together, the products together, right? I'm punching it in my calculator, so I'm not showing the separate work for each of those, but it's going to be 250.51 grams. We're adding here, so we are using the same number of decimal places. Alright, so which has more atoms? 1 gram of aluminum or 1 gram of nickel? So let's think about that. The molar mass of aluminum, we look on the periodic table, aluminum is 27.00 grams per mole. And for nickel is 58.69 grams per mole. Okay? So if I have 1 gram of aluminum and I have 1 gram of nickel, I'm going to have a lot more atoms of this. It's a greater percentage, right, than this is. Okay? So each of the nickels are heavier, so I'm going to have more atoms for the same amount of mass. Okay? So it's kind of like saying which has more feathers, a pound of feathers or a ton of feathers or a ton of bricks. You're going to have more feathers. Okay. Okay, so the mole mass of a substance is used to convert between moles and grams. 1 mole equals 1 molar mass. So how many atoms are in 100 grams of potassium? Well, I can take that, use factor label here, right? I have 100 grams of potassium. And what I know from looking at the periodic table is 39.10 grams of potassium is 1 mole of potassium. If I set it up right, the grams of potassium will cancel out, and I am left with 2.56 moles of potassium. Same number of sig figs as my given, 2.56. How many grams are in 15 moles of butane? Well, first I've got to find out how much 1 mole of butane weighs, right? So I have 4 carbons, each weighs 12.01 grams. I have hydrogen, I've got 10 of those, each weighs 1.01 grams. This is going to be 48.04. This is going to be 10.10. Add it together and I get 58.10 grams. So if I have 15.0 moles of butane, what I know is 1 mole of butane is going to be 58.10 grams of butane. And my moles will cancel out, and I'm not going to be left with grams. And if I take this 15 times 58.1, my calculator says 871.5, but I need 3 sig figs like this, so it's going to be 872 grams. Alright, and we can also use a conversion factor between particles and moles, because our conversion factor is 1 mole of anything is 6.02 times 10 to the 23rd things. Things can be atoms or molecules or pencils, just like I can have a dozen atoms, a dozen molecules, or a dozen pencils. It's not real practical to count pencils using moles, but it is practical to use moles to count atoms and molecules. So let's look at an example. So how many moles of magnesium are in 1.25 times 10 to the 23rd atoms of magnesium? What I know is 1 mole of anything is 6.02 times 10 to the 23rd. That's what I'm always going to use. So my given is 1.25 times 10 to the 23rd atoms of magnesium. And what I know is 6.02 times 10 to the 23rd atoms. Remember, I need to have the same units down here that I have here, is 1 mole of magnesium. My atoms will cancel, of magnesium will cancel out. And then 1.25 times 10 to the 23rd divided by 6.02 times 10 to the 23rd, and I get 0.208 moles of magnesium. 3 sig figs, just like the given. 1 more and then we're done. Alright, how many molecules are in 2.12 moles of propane? Okay, so what I know, I'm going to go from molecules to moles, so what I know is 1 mole is 6.02 times 10 to the 23rd anythings, right? In this case, we're going to use molecules. Alright, 2.12 moles of propane is my given. And what I know is 1 mole, I'm going to have the same units down here that I had here, C3H8, so that cancels out, is 6.02 times 10 to the 23rd molecules. Okay, if I multiply 2.12 times Avogadro's number, I'm going to get 1.28 times 10 to the 24th molecules. Alright, that's going to do it.